implicit differentiation. We're still doing derivatives. That's not going away. We are going to be with them for a while. But you'll notice everything we've done the derivative of so far was y equals. So it was in terms of y. Sometimes we have equations where it's not y equals, and we still need to be able to calculate a derivative. So let's take a look at this problem. If I wanted to do this derivative, what would I have to do first? Okay. When we worked through these, we always had y equals, and then when we did the derivative, we would call it y prime or something, right? And we did the derivative in terms of x. So what I want to do here, I should put directions here. My directions, I just want you to solve for y. So if we wanted to do the derivative based on what we've learned in the past, it would have to be y equals, so we would have to solve for y first. So if I wanted to get y by itself, what would you do?
Subtract x.
Okay. Divide by -1, so y squared equals x. Then to get rid of a square, we need, and with that, plus or minus, so y equals plus or minus the square root of x. What's the issue with doing this derivative? I mean, we could, but we're going to get, we have a plus and a minus in there, right? So it's maybe a step more complicated than the ones we've done before. Let's just do one more solving for y. What if I asked you to solve this one for y? What would you do?
Subtract the x.
Then to get rid of a square, square root, plus and minus, y equals plus or minus. Can you make this 10 minus x? No. It has to stay the square root of 100 minus x squared. Okay, so not necessarily pretty, but possible. We could solve for y and do them. But sometimes it might give you an equation where you can't solve for y. Like if I give you this one. We have a y cubed and a y. Do I really have much hope of solving this for y? No, it's going to be pretty ugly. What we can do is still find the derivative, but we're not going to solve for y first. We're going to keep all of our derivative rules, but we are going to do the derivative with respect to x. So when I do a derivative of an x, it's going to stay like normal. When I do the derivative of a y, I'm going to have to write dy dx, meaning derivative of y in terms of x, or y prime with it. I tend to use the dy dx because just from past experience, when you have y's and y primes in your problem, sometimes it's hard to tell the difference between a prime and a straight eraser mark, and you get confused very easily. So dy dx is probably a safer bet. All right, so I am going to use implicit differentiation to find the derivative of x squared plus y squared equals 100. Okay, it's really kind of like what we did before. When we did the derivative of y before, didn't we a lot of times write dy dx equals? So same idea. What's the derivative of x squared?
2x.
Plus the derivative of y squared. So we kind of treat it the same in our derivative rules. The 2 comes down, the y stays, subtract 1 from the power. But the difference is you have to put times dy dx. Every time you do the derivative of a y, it gets a dy dx with it. Equals, what's the derivative of 100? Now, I'm going to solve for dy dx. So if I subtract over my 2x and divide by 2y, dy dx is negative x over y. Notice probably easier than even trying to solve for y and then do the derivative of this mess. We didn't do the derivative here, we could have, but this is going to be a little bit nicer. So what we have to remember is every time we do a y, when we do its derivative, we put dy dx. So then with this, I asked you to find the slope of the tangent line at the point 6, 8. dy dx is the same thing as slope, so my formula is negative x over y, so negative 6 over 8 is negative 3/4. Is that okay? So let's do this one. I want the slope of the tangent line, and then I want to write the equation. So first step, slope of a tangent line is the derivative. Derivative of x cubed plus derivative of y cubed. 3y squared. What else does it need? dy dx equals 3xy. We technically have two variables here, an x and a y, so we're going to have to do a product rule there. So let's treat the 3x as one thing and the y as another. So derivative of the first, derivative of 3x is 3 times the second plus the first times derivative of the second. What would be the derivative of y? dy dx. Derivative of a variable is 1, but we know with that y we have to put dy dx with it. All right. So from here, I'm going to need the dy dx if I actually ask for the implicit differentiation. And I'll go ahead and do it this way. So if I want to solve for dy dx, I'm going to put everything with it on one side. And everything without it on the other. Both of these have a dy dx. So what do we do?
Take it out.
Mm-hmm. So then to get dy dx by itself, we can divide. Anything we can do to reduce that? Yeah, let's divide 3 out of everything. So my derivative is y minus x squared over y squared minus x. All right, so then I asked for equation of the tangent line. So my slope, that's the same as dy dx. So we have to go to our point. Y was 3/2. X was 3/2. And that should just be -1. So then plug into y equals mx plus b. Let's just practice some more. Alright, I have another equation of the tangent line. So equation of a tangent line, we know we need a point and a slope. To get the slope, we have to do the derivative. This is definitely not something where I could just solve for y. So let's talk about the derivative. On the left, we have an outside and we have an inside. So chain rule says derivative of the outside, inside stays the same, times derivative of the inside. What is the derivative of x plus 2y? Derivative of x would be 1 plus 2, and every time you do the derivative of a y, you have to put on the right. What am I going to have to do? Product rule. So derivative of the first, derivative of 2x is 2 times the second plus the first derivative of the second. So derivative of cosine is negative sine. Inside stays the same times derivative of the inside. Derivative of y is y dx. Okay, so here's a suggestion. Did I ask you to find dy dx on this problem? No, I just asked for the equation of the tangent line, right? There is nothing that says you have to solve for dy dx before you plug in your point. So if it looks kind of ugly, the origin is what ordered pair?
0, 0.
I could plug that in first. So I get the cosine of 0 plus 2 times 0 is 0. What happens to this whole term when you plug in a 0?
It's 0.
That's gone. What is the cosine of 0? 1. So this is 1 times that, so we just get 1 plus 2 dy dx equals 2 times 1, which is 2. So dy dx is in. So that's my slope. Y equals mx plus b. So the equation is just y equals 1/2 x.
Isn't it 1/3? Like the n? 1 plus 2.
Oh, I subtracted my 1 over first. And then I divided by 2.
Yeah, but the divided by 2, it's 1 plus 2 dy dx.
Mm-hmm. But like terms, you can't add these because this is multiplied with the dy dx. So I had to subtract my 1 to the other side.
Yeah, but in the parentheses. Okay.
Yeah, sorry, I turned
So-
this into a 1 times that. Kind of skipped a step there. Is that okay? All right. Let's try a few more. Why don't you guys see if you can do this one? guys get dy dx equals negative x over y? And then part B, the equation, so the slope would be negative 3/4. Plug into y equals mx plus b. So you get 25/4. So the equation is y equals negative 3/4 x plus 25 over 4. If I ask you to find y prime is the same thing as what? dy dx. So, derivative of x to the third would be 3x squared. What's the derivative of y to the third?
3y squared.
Alright, so then over here with the 6xy, we have to treat that like a product rule. So derivative of the first, derivative of 6x is 6 times the second, plus the first, derivative of the second. Derivative of y is dy dx. I don't have an actual point to plug in on this one. I'm just finding dy dx. I do have to go ahead and get it by itself. So I need all my dy dx's on one side. Then what do we do?
Pull down the dy dx.
And divide. Always double check to see is there any simplification we can do.
You can take that for 5.
Mm-hmm. I think I'm going to do the last 2 more examples and then I'm going to stop for this portion. The next problem I am going to change my direction. So. Any issues so far? What if on this one, let's change this, instead of finding y prime, I want you to find dx dy. What did I do there? Yeah, we've been doing dy dx. And to get that, every time we did the derivative of a y, it became dy dx. If I ask for dx dy, how do you think we get that?
Derivative of x.
Yes.
Dx.
Every time we do the derivative of an x, we have to put dx dy. Do we need anything with the y's here? No. What this means is do this derivative in terms of y. So y is our normal variable now. Anything else gets something different. So, chain rule. Derivative of sine is cosine. Inside stays the same. Times derivative of the inside. So derivative of x would be, and derivative of y would be 1. Okay, over here it's product rule. So derivative of the first, derivative of y squared would be times the second plus the first derivative of the second. Derivative of cosine is negative sine. Inside stays the same times derivative of the inside. Derivative of x would be dx dy. Okay. This is a little bit ugly. We have to distribute here. So we get the cosine of x plus y times dy dx plus the cosine of x plus y equals 2y cosine x minus y squared sine x times dx dy. Alright. Now what?
Get dx divided.
Okay, am I going to confuse you guys too much if I add this over and factor out my dy or dx dy at the same time? I switched that, didn't I? I put dy dx there. Sorry, habit. So I'm going to add that over. Can I pull out this dx dy at the same time? So it'd be dx dy times cosine of x plus y squared sine x. Over here we have 2y cosine x, and I'm going to subtract over cosine x plus y. So final step would be to divide. So point of that is really just we can do it in terms of either variable. You just have to watch. Is that one okay? Let's go ahead and do one last problem. So what am I asking for on this one? Second derivative. So we have to do it twice. So derivative of x to the fourth would be 4x cubed plus derivative of y to the fourth
4y cubed dy dx.
derivative of 16 So if we divide, we get negative x cubed over y cubed. That's the first derivative. And I wanted the second. So we're going to have to do it again. So the notation, it's actually d squared y over dx squared. That means second derivative. You're welcome to call it y double prime. I just think tick marks easily get lost in these problems. What would I have to do this derivative?
The quotient?
Yes. So low d high, derivative of the top would be negative 3x squared, minus high, d low. The derivative of y cubed would be 3y squared dy dx over low squared, y cubed squared would become y to the 6th. Okay. So that's negative 3x squared y cubed plus 3x cubed y squared. But what is dy dx?
Of that.
I can put in a negative x cubed over y cubed. So here, 2 of these y's would cancel. We don't like a fraction in a fraction, do we? So the easiest option is just take top and bottom times a y. So we get negative 3x squared. If I multiply by y, that's now y to the 4th. These y's would drop, so I have 3x cubed times negative x cubed, so negative 3x to the 6th over y to the 7th.
Wait, why did you change it to y to the 6th on that one?
Over low squared, so x cubed squared becomes x to the 6th, or y cubed squared becomes y to the 6th.
Okay, so why did you take out the 3x cubed y squared? Like, why did you take out the y squared?
Oh, I canceled it with the denominator of this fraction.
So then, I was really lost, actually.
Okay.
I just don't really
So let's
understand where
back
they're-
up here. So right now we have negative 3x squared y cubed. If I multiply those, that's negative 3x to the 6th over y squared, 2 y's on top and 1 on the bottom leaves 1 on the bottom. Okay, so that's what I got if I just plug this in. And then I said, well, we don't like a fraction in a fraction. So to get rid of that, let's take top and bottom times a y. Distribute it here, so that's where I got this y to the 4th. When you take it times this one, these y's drop. And then on the bottom it became y to the 7th.
Okay, now I got the same answer.
Okay. All right, I know we're not done with this. Technically, you could work up through 46 or 36 right now. So that's 13 problems.